In this video, I'm going to go over the steps that I took to set up a Windows Mini PC to control my Celestron NexStar 6SE telescope on a Wedge. The software components for this setup are the same as those that you would need to configure in order to control your telescope with a laptop, and similar to those that you would need to set up a computer to control your German equatorial mount. Hi, my name is Chris, and welcome to my channel. I have been running this rig for a couple of years, controlling it with this older model i3 CPU Lenovo IdeaPad laptop. Now, my rig includes this orange tube Celestron NexStar 6SE on a NexStar mount. It has a focus motor. It has a guide scope with a guide camera. That's the SV-Boni or SV-Boni 905C guide scope, and a ZWO camera, the ASI 294 MC Pro. So those are all components that I would need to control with a computer. Now, in order to control all of those components with a computer, I would need to run USB cables all the way from this rig to where I had my laptop. Now, initially, I had all of those cables going through a single USB hub. But I found that that was a bottleneck, and my connection kept dropping out for my primary imaging camera. And so I changed that up, and I was using two cables, one USB cable for the imaging camera and another USB hub with shorter USB cables for everything else. Problem with that was that, first of all, it was a lot of wiring, big wiring harness to set up and take down every time I wanted to set up the imaging rig outside. Also, the cord wrap was always a danger with so many cables going back and forth. And the imaging camera, the cable, had to be at least 6 feet long in order to reach from where I had the telescope mounted on a high wedge to where I had the laptop. And even though I wasn't really dropping connections anymore, the connection wasn't all that fast. So I was looking for an alternative where I could contain everything to one rig, so I could pick the whole thing up and go without worrying about connecting and disconnecting a whole whack of cables and worrying about leaving a laptop bolted outside. So for that reason, I decided to switch things up and get a little mini PC to run this setup. Now, why a mini PC like this and not something like an ASI Air or a Astro station? Well, personal preference, really. For one thing, this is a mix of mostly Celestron, SV-Boni, and ZWO components, so the ASI Air wouldn't work for everything. And I really didn't want to be tied down to proprietary hardware and software. So I wanted something that was much more flexible, where I could switch things out as I pleased with whichever software I pleased. I found that with using the laptop, I ended up using a whole host of different solutions depending on what I was using the rig for. And that kind of flexibility meant that I would need to go under the hood and change out some of the software components that I was engaging and how I was using them. So for that reason, I thought going with a little Windows Mini PC would be a pretty convenient option. Now, I understand that the interface for a mini PC is not as slick as the phone interface that you would get with a dedicated device, but that's just one of the trade-offs. For me, this seemed like a pretty good solution. I'm pretty happy with it. I've broken out what needs to happen next into 5 sections. The first of which covers off some of the before you get started types of activities. The next one talks about some of the additional tasks you should perform when setting up a new Windows machine for astrophotography. Section 3 covers off some of the physical installation considerations when setting up your new mini PC. The fourth section deals with downloading and installing the software you will need to control your mount and your imaging cameras. And finally, the last step deals with configuring your control software. And that one there is broken out into part one, which deals with the types of things you can do inside, and the second part, which is really the first light, the things you would need to do when you take your entire rig outside for the first time with your new mini PC. So let's get started. The mini PC I ended up getting was the Boss Game B95 mini PC with Windows 11 Professional. Now this is one of those, I guess, cheap, no-name-ish brands that you get on Amazon. It cost me a couple $100. I liked it because, first of all, it had 16 gigabytes RAM and a large hard drive. So it has a 512 gigabyte built-in SSD. And I wanted the extra storage so that I'd be able to do long imaging sessions, maybe over a couple of nights, without having to worry about downloading the files and clearing out space. The other thing I liked about it, it has a 3.4 gigahertz N95 12th gen CPU. That's not super fast, but it's certainly enough for what I needed to do here. Given that I was running everything off of an i3 older model processor, I thought this would be enough, and it did turn out to work out quite well. The mini PC supports 4K UHD dual HDMI ports. Now I'm not using those, but it's nice to have. I did use them to set up the PC, and that's about it. It has Type-C USB port and 4 regular USB 3.0s, which worked out quite well because I needed all 4 of them in order to connect my telescope mount, my main imaging camera, my guide scope, and my little USB live camera that I use to keep tabs on what's going on with the telescope itself. The mini PC also has Bluetooth, which is very convenient for something like an external keyboard. Now, before I got started, I wanted to take a full backup of the hard drive that came preloaded on the mini PC, and that's before I even started setting it up. So I took it out of the mini PC, put it into an external enclosure, and used a software package called EaseUS to take an image of that entire partition, actually of the entire drive, so that if I messed anything up, I could always go back and restore it. Once that was done, I put the hard drive back in, powered up the mini PC, and went through the Windows setup steps. Although I'm not going to be covering the Windows installation, I do want to point out 2 things. One, make sure once you've gone through the Windows setup process that you perform all of your Windows updates to make sure that your operating system has the latest patches and updates. And 2, I like to extract the Windows license key once the installation completes. And this is in case anything goes wrong and I need to reinstall Windows from scratch. If you have an OEM version of Windows that ships with one of these pre-installed PCs, this might be the only way that you can get at the license key. So what you can do is start a command line in administrator mode and execute this command that is in italics. I will be providing this command in the video description below as well. Okay, step 2. Change your Windows update settings and adjust active hours. So you do not want Windows firing off a Windows update in the middle of your imaging session. And for some reason, Microsoft thinks that the active hours that you're going to be using your PC are during the day. So you will have to change this to let Windows know not to do anything at night that would affect your imaging. Another thing you might want to do is set your power options to never turn off. Last thing you want to do is have your mini PC turning off in the middle of a session. Next, create a local user that you can use to access your mini PC's network shares remotely. and then go ahead and set up a network share so that you can connect to your saved images and download them to another computer. Finally, and this one here is a little bit risky, I'm going to be disabling my firewall. And this is because I don't want to be struggling with Windows networking issues when I'm trying to connect from a tablet or my phone at 4 a.m. in the middle of nowhere. Now, if you want to do this properly, you can set up your firewall with the proper rules to permit access for the devices you're going to use. But again, this is a personal preference and a risk you'll have to take on if you decide to disable the firewall. Step 3. Figure out where you're going to place your mini PC on your mount. You want to make sure that the location is accessible while at the same time not impeding the operation of your mount or disturbing your scope's balance. You also want to make sure that the setup is going to look really cool. Otherwise, the other astronomers will make fun of you. One of the challenges for me was always going to be how to mount the mini PC onto my rig. Initially, I wanted to put the little mini on top of my piggyback adapter. That's a piggy adapter that I had used in the past to run my DSLR, and now it serves as a spot for my USB live cam so that I can monitor sky conditions remotely. The more I thought about it, the more I disliked putting the PC there because 1, it would take away a perfectly good mounting point for other cameras, and 2, because I thought there would be a better place to put this thing that would better balance the entire assembly. And so I opted to put it underneath the rig. The way my rig is set up, in order to avoid hitting the mount when pointing way back at Polaris, I have pushed the OTA very far forward, and in order to do this, I had to add an extension dovetail. Now this in turn pushed the primary mirror past the midpoint where I mount the telescope, which then necessitated me adding an extension bar with a counterweight. Obviously, this blows out the weight limits of the mount. I understand that it's a risk I'm taking in order to be able to run the rig this way. But it also gives me the opportune place to mount the mini PC. So here's what I did. I got a little T bracket and an L bracket which I bolted together. And then I bent the T bracket so that the entire assembly took the shape of an S. With the top portion mounted to the extension bar with a couple of metal screws and the bottom connecting to the mini PC. This almost fit perfectly, except there are 2 little knobs at the bottom of the focus motor which got in the way. And I had to bend the bracket a little bit at the bottom so that the mini PC sits slightly askew, but still fits fairly flush, and all the cables are completely out of the way when connected. We're going to need software for standards and interfaces, control software for our mount and telescope, guiding software, plate solving software, and additional drivers for our cameras, not to mention actual astrophotography image capture software. That's no fewer than 7 different software packages plus drivers. Now that's a lot of information to cover off in a couple of slides. So why don't we quickly go through each of the software elements? I will be providing links to all of the software in the description. The software we're going to be using includes ASCOM, or the Universal Standards for Astronomy drivers, Celestron's Plane Wave Instruments Telescope Control Software, CPWI, the specialized ASCOM driver for Celestron telescopes. This is the Unified Celestron Telescope and Focuser driver, which we're going to be using if we can't use CPWI. PHD2 guiding software, SharpCap image capture software, which I use for planetary, as well as to run my live cam so I can see off of the nose of the telescope. Astrophotography tool, image capture software. Backyard Nikon. This is Backyard Nikon / Backyard EOS DSLR image capture software. I used to use it pretty much dedicated with my Nikon camera when I was using my DSLR exclusively for imaging. I still use this software when I need more complex imaging plans for the DSLR. I find that Backyard Nikon contains more drivers and support for camera bodies that other software packages do not. Svibony camera drivers, whether you're using a Svibony imaging camera or if you're using a Svibony guide camera, you will need these drivers. ZWO drivers, so I use a ZWO camera. My main imaging camera is the ASI 294 MC Pro. If you have an ASI camera or a ZWO camera, you will need these. And next is a series of software required for plate solving, which are integrated into Astrophotography tool, the image capture software that I use primarily. If you're using Nina, you will likely need these as well. The first of these is the Astrometric stacking program, ASTAP. You will need the program installer as well as one of the star databases. I use the D80 database, which is the largest database and contains pretty much all the objects across the sky. Next up is the All Sky Plate Solver. This one here is another plate solving program also used by APT. And finally, plate solving, plate solve 3 rather. Here's a link to it from this other web page. This is the nighttimeimaging.eu page, which contains a whole slew of information on plate solving, including a direct link to Plate Solve 3, which is a plane wave instruments produced piece of plate solving software and is also used by APT and Nina. Let's go on to the actual software installation, starting with ASCOM. Now to do this, you can either follow the link in the description or you can Google ASCOM platform to get to their website. Once there, select the latest platform. For me, that currently is platform 7.0. When the file downloads, you can execute it right from that location, or you can do what I do, which is move the software to a software folder so that you can reference it later. Once you've started the installer, I took the default options. I don't need the simulator or the old hub drivers. Once done, click Finish. We're going to do the same thing for CPWI. So let's Google CPWI, or again, you can click on the link in the description of the video. Once you're on the Celestron webpage, click the Download Software link to start the download. For me, it started automatically. Once complete, once again, I've moved the software to my software folder, where I created a subfolder for Celestron, and I launched the installer. You can go ahead and do that and accept the changes that the software is going to make. Take all the default values unless you want to change the installation location, and let the installer do its thing. Once done, once again, press Finish. Now on to PHD2. Here's another simple install. Simply either Google PHD2 guiding or use the link in the description to download the software from the web page. I'm once again selecting a Windows version because that is what we're installing on this mini PC. Once the download completes, I'm going to once again take the install file and put it into a subfolder within my software folder. Now in this case, we're getting a Windows notification that this is not a trusted publisher, so I'm going to skip that over and I'm going to let the software make the changes. Once again, there's not much to set for the software other than the install location, so we're going to go ahead and run the installer. And once done, click Finish. One thing that I like to do is to put shortcuts to all of the software on the desktop. That way, if I'm using a touchscreen or if I'm in a hurry, I don't have to go searching through Windows menus and I can launch the software directly. So if that's something that you'd like to do, then go ahead and do that as well. Next up, we have SharpCap, and as usual, either go directly to sharpcap.co.uk and look for downloads, or click on the link in the video description below. Once there, scroll down and look for the latest download version. As usual, I'm going to copy it into my software folder, and from there I'm going to launch the installer. Finally, once the installer is complete, we're going to click Close. And finally, we're going to install Astrophotography tool. You can grab the link from the description or go to the astrophotography.app website to find the download link. I have a saved version of the software I've already downloaded because I do have a licensed version and I want to use the same release. So I'm just going to grab it from my saved location. From there, we just run through the installer. And at one point, the installer is going to launch the Visual C++ redistributable, and it's going to go through that process as well. And once the installation is done, we can go ahead and click on Finish. Here are the ASCOM drivers for Celestron mounts and focusers. I use this driver when I can't use CPWI. Specifically, I use it with my SLT mount. But I can see occasions in the future where I may want to skip over CPWI and use another piece of planetarium software to control my mount. And I think this driver would come in pretty handy for that. I found it on a Cloudy Nights blog with a link that goes directly to it, but I will put a link to the driver downloads for ASCOM down in the video description, as with all the other software components. It's a quick download and a quick install, and done. Here's Backyard Nikon. For Backyard Nikon, again, follow the link in the description. This is a licensed piece of software, which I think comes with some limited functionality if you want to preview it. Now, I do have a license, so I'm downloading it using my account. And as usual, moving it to my software folder from which I'm going to launch the installer. The installer is going to prompt me to confirm that I want to run an unknown publisher piece of software, so I'm going to go ahead and say yes, and I will take the rest of the default values for the rest of the install process. And at the end, we're going to once again press Finish. At this point, we're going to need some additional drivers in order to make our hardware work. The astrophotography imaging software is going to talk to ASCOM. ASCOM is going to talk to the hardware drivers, and the hardware drivers are going to talk to our hardware. In this case, our cameras. I'm using Sfibani and ZWO cameras, so I'm going to the Sfibani website to download the Sfibani camera drivers, and then to ZWO to do the same for my ASI 294 MC Pro. Once I have the drivers downloaded, I'm going to quickly run through their installers to get them loaded on the mini PC. Now, in this case, you may have noticed that I'm grabbing both the native SVBony driver as well as the ASCOM version of the SVBony driver. This is because some software, like SharpCap, would like to use the native Windows driver, while when integrating with ASCOM components, we would need the ASCOM version. Here I'm quickly testing to make sure that SharpCap can connect to my little webcam so that I can monitor my telescope. Here again, for ZWO, I'm going to download both the Windows native version as well as the ASCOM version of the drivers, and I will install both of them. This is the control software configuration portion of the setup. Here what we're going to do is we're going to configure Astrophotography tool and PHD2 guiding software. For APT, we are going to set up plate solving, which is going to enable APT to find targets for us in the sky by comparing where the telescope is pointing to maps of the sky that plate solving uses to determine exact locations. And APT can use in turn to tell the mount where to go and what adjustments to make in order to arrive at our target. We will also be configuring the color schema for APT if you don't like the default beige brown look, and we're going to be updating the safe path locations. So if you have a preferred place that you want to save your images, we can do that here. For PHD2, we're going to be creating a new profile and connecting our hardware. Then we are going to be creating a dark library and a master dark frame in order to identify bad pixels for PHD2 to avoid when guiding. To begin with, I've gone into APT, into the Gear tab, and there I've selected PointCraft and then PointCraft Settings. Under PointCraft Settings, there are going to be 4 sections for different types of plate solving utilities. Each utility has a corresponding download link, which will take us to the utilities website. Now, I'm going to be using 3 different types of utilities. I'm going to be using ASTAP, I'm going to be using PlateSolve 3, and I'm going to be using All Sky Plate Solver. Each of these utilities has a different use by APT when plate solving. For ASTAP, we're going to have to grab the program installer, and I will take the D80 Very Large Star Database. While that's downloading, I'm going to grab All Sky Plate Solver and PlateSolve 3, which is also a very large download. The D80 database is over 1 gigabyte, while PlateSolve 3 is over 5 gigabytes in size. Once all the files are downloaded, I'm going to once again create separate folders for each one of them and move the files to their corresponding folders. Next, we're going to go through the ASTAP setup, taking all default options. PlateSolve 3 comes as a zip file, which we will need to extract or uncompress before we can use it. Here's the uncompressed or extracted folder. For the D80 star database, we're going to create a separate folder. We'll put the database into it, and then we will launch the application, as it is an executable. The installer is going to unpack the star database into the same installation folder as where we had installed ASTAP. That's why I think it's important to keep all of the default file paths. Now we can run through the setup process for All Sky Plate Solver. Once again, taking all default values. Once that is all done, we can go back into APT and set all the paths for the plate solving tools. Next, let's go under APT Tools and APT Settings. And finally on this screen, we can change our image path location. That's the path that our images are going to be saved to. And we can adjust the color scheme from the brownish orange color to something else if we so choose. This next step of configuring PHD2 guiding can be done once you have your rig outside for the first time, or you can do it inside, provided that your telescope is connected and powered on. For my setup, I'm going to choose the Sfibani camera from the camera dropdown. This is going to be my guide camera. And for the mount, I'm going to pick the CPWI ASCOM driver. Now, of course, for this to work, CPWI is going to have to be up and running and connected to the telescope. And here we can see in PHD2 that my connection to my Sfibani camera and to my mount via CPWI are both showing green. So I'm going to go ahead and create a new profile for this equipment configuration. I'm also going to delete the default profile that PHD2 has loaded. Notice that I had to reselect the camera and mount when creating the new profile. Once this is done, I'm going to go into the Darks menu and I'm going to create a new Darks library and master dark for PHD2 to use in order to determine bad pixels when guiding. I'm setting my minimum and maximum exposure to the exposure lengths I know I'm going to be using, which for the NexStar mount is going to range between 0.02 seconds and 1.5 seconds. By the way, I am cutting and skipping a lot of the time-consuming processing that's happening here for brevity, as many of these operations take many minutes to complete, sometimes longer depending on the speed of your computer. Once the dark library is complete, we're going to create a bad pixel map, which is going to generate a master dark frame. This should be the last of the pre-shakedown steps. If I forget to mention it later, there is a setting in PHD2 where you specify your focal length of your guide scope. This is necessary in order to show your guiding error in arc seconds instead of pixels. So just something to be aware of, just in case it slips my mind later on in this video. But at this point, I think we're ready to go outside. Fantastic. We've gotten quite far. At this point, our telescope is outside and turned on, and we are ready for first light. So what we're going to do next is run CPWI Run and configure PHD2 by connecting the hardware through the profile that we've already created and performing a calibration, which is going to inform PHD2 as to the responsiveness of our mount to guiding commands, as well as the orientation of the guide scope in relation to the motion of the mount. We are also going to start up Astrophotography tool, where we're going to connect the camera. We will check our Bayer pattern, test our live view, connect our telescope/mount, and we will also focus the telescope. And then lastly, we will test our imaging, and there we're going to focus the telescope using either the focus aid in APT or a Batonov mask. We'll use plate solving to navigate to a target. We will enable guiding, create an imaging plan, and run that imaging plan in order to image a target. We'll also create a plan for our flats, and we will create some dark calibration frames. At this point, my telescope is already outside on the pier, and it is powered up. And I've already launched and connected CPWI so that I can go right into setting up APT and PHD2. When you start up APT, it comes up with this little helpful checklist, which you can use to make sure that you don't forget any initial steps when setting up your imaging session. Typically, if your camera is already powered on, then APT would already pick it up. Although for the first time, and or if you launch APT without the camera on, you will have to click on Connect Camera and then select the camera you plan to use. So in my case, I'm using my ZWO camera, and right away APT populated that it's the ASI 294 MC Pro. And my Bayer pattern is RGGB, which was already selected. Now, you do need to check the Bayer pattern for your camera and make sure that the correct Bayer pattern is checked or is selected in that dropdown. At this point, it's probably a good idea to check whether or not your camera is working by switching on live view. And if you don't see anything in live view, just increase your gain and your exposure until the video is bright enough for you to be able to see the stars. Now let's head back over to CPWI and perform an initial alignment in order to give CPWI a basic pointing model and help to orient it as to where the telescope is pointing in the sky. Now before we start, we have to check the little wedge option if we're using a Alt-AZ mount on a wedge, like the NexStar mount that I'm using. Next step, we're going to select our location if this was the first time using CPWI, and or if we are at a new location. And the easiest way to do that is to select from a map, which pulls up Google Maps and lets us drop a pin in our current location and then populate it back in CPWI. Now that we have our location selected and we've made sure to check off the wedge option, we can go ahead and do the alignment. You may have noticed that my preview did not have the correct colors. This is because I forgot to check the box to use the Fits Color Preview when setting up my camera. So I'm going to have to go back and adjust that. The other thing I wanted to mention is that CPWI gets its time from your system clock. So you need to make sure that in Windows you set your correct time, your correct time zone, and your correct daylight savings times options. With a wedge, the first thing CPWI will ask us to do is to point the OTA at the celestial equator and the prime meridian. If you're not sure how to do that, I do have a couple of videos on aligning a wedge-based mount and a video explaining how wedges work if you're interested in seeing that. Following the instructions in CPWI, once our telescope is pointed south and at the equator, we're going to select a star for it to slew to, and then we are going to center that star. Once that first star is centered, we're going to do the same thing with a second star. I'm not too concerned about the pointing model in CPWI because I'm going to be using plate solving to find my destinations. That's why I'm only doing a 2-star alignment here. Next up, I'm going to go back to APT and connect my telescope mount, which is just connect scope, and my focuser. As this is the first time making that connection, APT is going to ask me to select which driver I want to use. And since we're using CPWI to control our mount, we're going to pick that for both the scope and the focuser. When selecting one of these drivers, the ASCOM chooser is not going to let us click OK until we look at the properties first. Once our first 2-star alignment is done, what I like to do next is focus. Now there's 2 ways that you can focus here. My preferred way is using a batted off mask, or we can try the built-in focus function in APT. Other tools like Nina have this function as well. In APT, this will be found under the Tools setting and is actually a 2-step process where first we're going to have to click the Focus Aid in order to bring up the box that will help us frame the star that we want to focus on, and then there is the Autofocus Aid, which is going to perform the autofocusing itself. I'm going to be using the FWHM method, and I'll just select Run to let APT run through 12 cycles of trying to find the right focus. APT will fit a curve against the data points that it gathers, and using that curve, it will determine the best focus. Personally, I prefer to use a batted off mask to be sure that my focus is the best that it could be. Then we'll head over to PHD2, and here we're going to, first of all, enable the bullseye view. So I like to enable this view so I can see where the stars are in relation to the center. Then we'll select the auto star selection and we'll hit the guide button. Now the guide button for the first time is going to do a calibration where it does steps to the west and then back to the east to bring the star back, and then it'll do the same thing north and then south. And that's going to create a calibration model which PHD2 will be able to use to determine which way the mount will respond to various guiding commands. For less expensive mounts like the NexStar, you're very likely going to get a message that your calibration varies unexpectedly in RA and declination. You can check the graph to make sure that it looks relatively okay, that it's not all over the place, that you don't have a wild, acute, or obtuse angle to your calibration. But in most cases, for these focal lengths, you should be fine. And if necessary, you can perform the calibration again by holding down the Shift key before you click Guide. It's time for us to image our first target. When imaging, it's important to use proper calibration frames, especially darks and flats. I typically do these either at the beginning or the end of an imaging session. In this case, I'm going to do them at the end. With the scope settled, we're going to take a quick picture through the camera. This is for the purpose of plate solving the current position. Now we can go ahead with plate solving, and in APT that is found under the Gear tab and the Point Craft button. There, we're going to click the scope position in order to seed the position of the telescope to where it's at right now, and then the Solve button so that plate solving can use one of the mechanisms we had set up earlier to determine the actual orientation of the telescope. We then click the Sync button to sync that up with the telescope, so that the telescope knows where it's pointing. Finally, we can click on the Objects button down below and select the object we want to slew to from the list. If the object isn't in the list, we can simply put in the RA and DEC right into the center FOV at position coordinates and click on Go To so that the telescope will slew to the target and use plate solving to make adjustments as necessary to center the target for us in our field of view. Now that we found our object, we're going to check in with PHD2 to make sure our guiding is on and accurate. And then we'll go back into APT, and in this case, since we're using APT for the first time, we're going to clone one of the light plans with the parameters that we want. I typically use 180 seconds or 3 minutes for exposure times, and the gain ranging between 120 to 240 depending on what I'm imaging. And in terms of the count, well, that's going to be 20 images per hour, so I would set my count accordingly. Once that's done, we're going to start the plan and then sit back and wait for it to complete. I won't be covering taking calibration frames in this video as it's already getting pretty lengthy, but if you're interested, I do have a video on something called UPPDMAT, which is a type of sky flat that I typically use that you're welcome to have a look at. So hopefully you guys have found this helpful. And if anyone has any suggestions, if you've noticed that I've missed anything, please do let me know. Otherwise, as always, thanks for watching, and until next time, clear skies.